All right, welcome to the second video following up on the first two examples for lesson 37, area of combined polygons. All right, example 3 here. Again, pause if you need to so you can copy down the example. In example 3, we've got a lot of information going on. There's going to be quite a bit of work involved in this problem. It says in the figure, AD, which is this side right here, is measured at 40 centimeters. And then they tell us that DC is measured at 30 centimeters, so that's this side here. And they tell us point B is in the middle of AC, right? It's the midpoint of AC, so it's got to be right dead in the center of this line segment, which means that this segment and this segment have to have the same size. And then we're told that point E is in the middle of AD, that line segment, which means this side and this side have to have the same size. All right, so if that's the case, then if I knew what the length of this long side was, I could split it in two and I would have this side AB and then this piece BC. And I already know, since this AD side is 40, I know that this has to be 20 and this has to be 20 because the point E splits it into two equal pieces. All right, so really I'm trying at first to figure out what what AC is, this long side AC. And to do that, I'm going to use the Pythagorean theorem. If I take 40 squared, the leg of this big triangle here, all right, this leg is 40 and this leg is 30. If I take 40 squared plus 30 squared, I'm going to get my AC squared. And this is really just a Pythagorean triple. It's a 3, 4, 5. But let's see the math here. 40 squared is 1600, 30 squared is 900, and then we've got the AC squared. And again, we don't know what the AC squared is yet, but if we add these together, we get 2500 equals AC squared. Well, 2500 just happens to be the square of 50. So 50 equals AC. Of course, if you can't do that in your head, what you can do is you can take the square root to get it, the square root of both sides. So AC must be 50. So if AC is 50, that means this side must be 25 and this side must be 25, this little segment, because AB and BC are equal. All right? So then we move on to still trying to find the perimeter. I didn't really read that far, but it says find the perimeter of the area. And the area. I'm sorry, I missed that. Find the perimeter and the area of the quadrilateral BCDE. Well, if I want this perimeter, the pieces in red here, then I need all four sides of it. Well, I have three of them. This is 20, this is 30, this is 25. I don't have EB. Well, to find EB, I can take the area of, I can use Pythagorean theorem to find this measurement right here. So follow along with this. I can take the 20 squared plus BE squared. BE is that side measurement. That's going to be one of the legs. Leg squared plus leg squared equals hypotenuse squared. So 20 squared plus BE squared equals 25 squared. And this is another Pythagorean triple, actually. 20 squared is 400 plus BE squared is equal to 625 when you square 25. And then if we subtract BE squared, must be equal to 225. And that means BE must be equal to 15. If, again, you can't think of the number that needs to be squared in order to get 225, you take the square root of both sides and you get 15. All right, so that means this side must be 15. So our perimeter is real simple. It is 20 plus 15 plus 25 plus 30, which comes out to 90, and our units are centimeters, so 90 centimeters is our perimeter. All right, this question also asked us, however, to find area. I'll change colors here for the area. The area of the quadrilateral would be the area of just this part of the quadrilateral. And like the previous, no, not like the previous example, I'm sorry, we haven't done one like this yet. In order to find this area, we're going to take the area of the large triangle and we're going to subtract the area of the smaller triangle from it. All right? So if I take the area of the large triangle, that is 1/2, let's call this area L for large, area of the large triangle. That's 1/2, the base is 30 and the height is 40. So 1/2 of 30 times 40, that's what? 1/2 of, I'd rather do half of 40 is 20. 20 times 30, excuse me, is 600. So the area of the large triangle is 600 square centimeters, and the area of the small triangle, has 1/2. The base is 15 and the height is 20. So 1/2, 15 times 20. And again, I'm going to say, all right, well, half of 20 is 10, and then 15 times 10 is 150. All right? And so the area of our quadrilateral, the area of, what is it, BCDE, is a subtraction, 600 minus 150, which is 450 square centimeters. All right? If you need a little bit more help to understand what happened there, feel free to rewind the video, watch it again, slow it down, whatever you have to do. All right, let's move on to example 4. Example 4 says find the area of the shaded region. Dimensions are in centimeters. So this is very similar to the problem we just did. All right, I need this area shown in the blue. And so in order to find it, I'm going to begin by finding the area of the large triangle. So the area of, I'll call it L for the large triangle, is the formula 1/2 of base times height, which of course is 1/2. Our base is the entire length, which is 80, and the height is this big height, 40. So that gives me 40 times 40 is 1,600, and that is in square centimeters. All right, then I've got the area of the small triangle, that is this triangle here, right? The area of the small triangle with 1/2 base times height is 1/2. The base is 40, the height is 20. 1/2 20 times 20, I'm sorry, 1/2 40 times 20 is basically 20 times 20, which is 400. And so the area of our shaded region, the area of the quadrilateral that we're looking for, is the subtraction 1,600 minus 400, 1,200 square centimeters. All right? Hopefully that wasn't too complicated. That makes sense to you. You can stop the video here and go on and begin the homework.